In this episode of Sometimes What We Think We Know Just Isn't So, the design intent is for an arc slot with a ramp bottom. And so in this proposed solution, a surface body was created with a certain ramp value distance below this face and a decreasing distance at this end. And then a simple extrude was done down to this swept surface. Now, if we take a look at this, in the section view, anywhere along that slot, we see that the bottom of this surface is a horizontal straight line. But if you worked out on the shop floor and you cut a slot like this with a typical end mill on a milling machine, you realize that this slot isn't perfectly straight line flat like that, even at the ramp angle. And you'll see an arc at one end or the other end of the slot that is at a flat plane. So let's look at an alternative solution to this. Here I have done the same part in Autodesk Inventor Professional. I'm going to drag my end of part marker up. So I started with a piece of stock, and so this is my beginning depth, and either beginning depth or ending depth, and then vice versa, either beginning depth and ending depth. So we know that the tool is going to, let's say if I start at this end, it's going to start here and it's going to ramp out until it gets up to here, and then it'll come out of the part. Now I'm going to suppress these two features. I don't need those. I just want to show that beginning position and the end position. So let me suppress those. So I'll suppress that feature and I'll suppress this feature. So what I did then is I did a surface coil. We can see if we can see the visibility of that. We might not be able to see it too well unless I go to wireframe because it's down inside there. But I have this ramp surface coil, but I did this as a helical ramp, not as a straight sweep. But it doesn't really matter. For the purpose of this problem, it doesn't matter what type of ramp that you had. The end result is, we'll see, is a little bit different than what you might expect. So the ramp type is not an important part of this problem. But then I found the actual curve. So this arc is the path the center of the end mill will follow in cutting that ramp. And again, it could be any mathematical shape that you need. The math of the ramp itself isn't the real consideration in this. So then I modeled an end mill cutter. I've already got it plunged down into the part. So that's the first thing. We'd either plunge down here at this end, or we'd plunge down here and come down to here and then come out one end to the other. And then in Autodesk Inventor I did a sweep cut, and so I'm going to edit that feature. And so you can select the solid that you want to use as a tool body. In this case, my end mill is a tool body. I select the path that I want it to follow, in this case this curve, and I tell it I want to cut then from this solid. So that's a swept solid cut in Autodesk Inventor Professional. Let me turn off the visibility of the surface body. I don't need to see that anymore. And so there is our cut. So if you have done something like this out on the shop floor, this is what you'll see. You'll see a circle at one end or the other depending on the direction of the ramp, and then this curve and this surface out on the shop floor. You'll see that that surface isn't flat in the form of a straight line. Let's do a section view. So I'll do a section view like we did on the previous part, and let me look directly at that. And so you'll see that the bottom of this slot actually has a curve to it. It isn't a straight line going across here, and so the results might be different than what you expect. And on the shop floor you might actually see a series of arcs here depending on the resolution as the tool went up the ramp. It'd be a continuous series of arcs similar to this arc that was down here at the bottom, except there'll be another arc, you know, going all the way up here. And this is all the resolution of the machine, but it isn't flat straight line, these curves.